Section 1. A hidden river in the cosmic dark. In the vast, silent expanse of the cosmos, there are islands of light we call galaxies. Each one is a magnificent city of stars, dust, planets, swirling in a slow, cosmic dance. We have long studied these brilliant collections, believing we understood the empty space that separates them. But the universe is full of secrets, hidden in plain sight. Imagine two such galaxies, appearing as lonely specks in the night sky. They seem entirely separate, adrift in the great ocean of space. Yet we have discovered a connection between them, a hidden link that was invisible to our eyes for so long. It is a bridge, a colossal river of gas, stretching between them like an unseen thread, close up on the filament stretching across the gap. This is not a small or insignificant feature. This ethereal structure spans an immense distance, a length so vast it challenges our very sense of scale. It measures 1.6 million light-years from one end to the other. To comprehend such a number is nearly impossible. Light itself, the fastest thing in the universe, would take more than 1.5 million years to travel its length. This discovery whispers a new truth about the cosmos. So, how does one find something so faint and so vast, something that emits no light of its own? The answer lies not in looking, but in listening. For decades, astronomers have relied on powerful optical telescopes to capture the brilliant light of stars, glowing nebulae. But this bridge is not made of stars. It is made of cold, thin hydrogen gas, the most abundant element in the universe. This gas does not shine in the visible spectrum. Instead, it sends out a faint, almost imperceptible whisper, a weak radio signal at a very specific frequency. To find the bridge, we had to build ears big enough to hear it. The discovery was the result of painstaking work with enormous radio telescopes. These instruments are not like the telescopes we might imagine. They are vast arrays of dishes, sometimes spread across entire continents, all working together as a single, powerful ear. They listen patiently to the sky, collecting the faint radio waves that have traveled across millions of light years. Scientists pointed these telescopes at a region between the two galaxies. Slowly, painstakingly, a picture began to emerge from the static, like a hidden message being decoded from the background noise of the universe. What they found was astonishing. The faint signal of cold hydrogen gas was not just a random cloud. It was a coherent, continuous stream, an immense filament connecting one galaxy directly to the other. The data revealed a structure that was long and slender, a true bridge between these two great star systems. This was not a chance alignment or a trick of the light. It was a real physical connection, a river of raw material flowing through the intergalactic medium. It was a triumph of technology and perseverance. This method of discovery shows us how much of the universe remains invisible to our eyes alone. The cosmos is filled with phenomena outside the narrow band of light we can see: magnetic fields, gravitational waves, vast clouds of cold gas, all painting a much richer and more complex picture of reality. By developing new tools, like powerful radio surveys, we give ourselves new senses. We are learning to see the unseen and hear the silent whispers of the cosmos, uncovering a universe far grander and more mysterious than we ever dared to imagine. Section 3. A structure of unimaginable scale. Let us try for a moment to grasp the sheer size of this cosmic structure. The bridge is 1.6 million light-years long. This distance is almost beyond human comprehension. Our own galaxy, the Milky Way, is a grand spiral of perhaps 200 billion stars, yet it is only about 100,000 light-years across. The closest major galaxy to us, Andromeda, is about 2.5 million light-years away. This single bridge of gas is so long that it could span nearly 2/3 of that vast distance. Marketing diagram. Compare 1.6 million light-years to the 180,000 light-year distance between the Milky Way and the Large Magellanic Cloud. It is almost 10 times longer than the gap between our galaxy and its nearest large satellite galaxies, the Magellanic Clouds. But its immense volume means that it contains a truly colossal amount of material. The total mass of the hydrogen within this bridge is estimated to be equivalent to billions of suns. This is not just a faint wisp, It is a significant reservoir of the raw fuel needed to build new stars. This is a significant reservoir of the raw fuel needed to build new planets. This structure is more than just a curiosity. It is a key piece of the puzzle of how galaxies live and grow. We see the galaxies as they are now, but this bridge is a signpost to their shared past and a potential roadmap to their future. It suggests a deep, long-lasting gravitational relationship between the two. They may have passed close to each other in the distant past, their gravitational pulls stretching the gas between them like cosmic taffy. Or perhaps this bridge is something even more fundamental, a remnant of the primordial cosmic web, the very scaffolding upon which galaxies themselves were built. The discovery of this bridge is not just about its impressive size, it is about what it does. Gas is the lifeblood of a galaxy. It is the fundamental ingredient from which new stars are born. A galaxy that runs out of fresh gas will slowly fade, its stellar nurseries growing cold and dark. Vibrant blue stars will die out, luminous white stars will die out, leaving behind only old, red, dying embers of a once great city of light. For a galaxy to continue its brilliant life, it needs a steady supply of new gas. This bridge, this river of hydrogen, may be just that, a lifeline. This flow of gas can dramatically alter the destiny of the galaxies it connects. It can act as a cosmic fuel hose, channeling material from the intergalactic medium into the heart of a galaxy. This infusion of new fuel can trigger a spectacular burst of star formation. Imagine a sleepy, quiet galaxy suddenly roaring to life, its spiral arms lighting up with the brilliant blue glow of millions of newborn stars. The bridge could be responsible for orchestrating these grand episodes of creation, feeding one galaxy, feeding both galaxies, changing their appearance, changing their structure, changing their very evolution over millions of years. Furthermore, the bridge influences the galaxy's dance through space. Even though the gas is thin, its enormous total mass exerts a gravitational pull. This gentle but persistent tug affects the orbits of the two galaxies, binding them together in a shared fate. Over cosmic timescales, this gravitational link could be drawing the two galaxies closer together, setting them on a slow-motion collision course, culminating in a spectacular merger billions of years from now. When they do merge, this bridge of gas will be consumed in a final, brilliant firework display of star birth, creating a single, larger galaxy from the two that came before. Finding this bridge challenges our fundamental ideas about the universe's structure. Simulations often show gas falling via networks of smaller, less defined filaments. Single massive coherent bridges like this are rare in our models. Its existence suggests our understanding is incomplete. Perhaps these grand structures are more common than we think, hiding in the dark, quietly shaping galaxies across the universe. We may need to revise our theories to account for these immense, life-giving rivers in the sky. As with all great discoveries, this one answers one question only to create a dozen more. We have found the bridge, but our journey of understanding has just begun. There are still so many things we do not know. Precisely how did this structure form? Was it pulled out during a close encounter between the galaxies? Or is it a primordial filament of the cosmic web that they have been feeding from since their birth? Answering this will require us to build even more sophisticated computer models and search for similar structures elsewhere in the universe. We also have much to learn about the bridge itself. How much gas does it truly contain? Is the gas flowing smoothly in one direction, like a river? Or is it a more turbulent and complex environment? Are there any stars forming within the bridge itself, far from the safety of a parent galaxy? Imagine a star born in this lonely place, its only neighbors being the faint glow of the two galaxies millions of light years away. Future observations with even more sensitive telescopes will be needed to measure the motion of the gas and search for the faint pinpricks of light that might signify the birth of these lost intergalactic stars. This work will take time. It will require the combined efforts of scientists from around the world, using a new generation of telescopes on the ground and in space. They will watch this system over many years, looking for subtle changes. They will map the gas in ever finer detail, trying to read the story written in its faint radio whispers. Each new piece of data will add another piece to the puzzle, slowly revealing the history and the ultimate fate of this incredible cosmic system. The process is slow and deliberate, but it is how we push the boundaries of human knowledge forward, one faint signal at a time. For now, this 1.6 million light-year secret between galaxies stands as a powerful symbol of wonder. It reminds us that the universe is not a static collection of objects, but a living, breathing, interconnected system. Quiet, invisible rivers flow through the darkness, linking the fates of distant islands of light. We have the tools to find them and the curiosity to explore them.